My name is Cedric Givard. I'm a principal investigator at the Cambridge University Stem Cell Institute and consultant hematologist for the NHS Blood and Transplant. Recently, my group started working at a Stem Cell Institute looking at the issue of thrombosis that presents in patients who are severely ill with COVID-19. In this movie, you will hear several members of my group who've been working on this issue in my lab, telling you why they are doing the work and how they're approaching it. And I would like to extend special thanks to my collaborators at the University of Bristol, namely Professor Alistair Poole and Andrew Davidson and Dr. Ingeborg Hers.
We weren't specifically engaged in coronavirus research, but we have been investigating potential interactions between viruses that are similar to coronavirus and cells in the bone marrow that release platelets into the circulation called megakaryocytes for several years now. So we have an ongoing collaboration with another platelet group based at the University of Bristol. And following the closure of both our research institutes and after entering into discussions with other groups based at both universities, we realised that we have the expertise to generate cells in the GVARC group that can then be exposed to the virus in appropriate containment level facilities at the University of Bristol. We hope that these early experiments will lead to an understanding as to why infection with coronavirus leads to a higher incidence of clotting issues seen in the COVID patients who are seriously ill.
Yeah. Our experimental work began on the 4th week of lockdown, just after the Easter weekend. We had divided our expertise and had organised when each of us would return to the lab. This ensured that we would minimise the number of people required to be in the lab at once and make it easier to adhere to the social distancing rules.
We're very lucky to be working in a building where we've had great help addressing the logistics of getting a project like this up and running very quickly. Despite the lockdown, key staff helped us with the ordering, lab setup, and maintenance necessary to do science during the lockdown. However, it remains a challenge to coordinate between different lab members, especially with social distancing in place, as well as to keep up to speed with such a rapidly changing field. It has been really interesting to see how quickly the project can get up and running despite the current situation.
With the technology available today, it's made it a lot easier to return to the lab when most of the lab is still working from home. We use Microsoft Teams, Zoom, WhatsApp for regular meetings, chats, as well as virtual coffee breaks. We can share data and receive feedback, and sometimes it's a lot quicker than actually looking for someone in a large building. Well, at first it was like coming to work at the weekend to do some cell culture maintenance, but after a few days, the big con was that it did feel quite lonely. It's different from working from home, where everyone's had to adapt. So coming into an almost empty building every day, where I was used to seeing friends and colleagues, it emphasised how quickly so much has changed. The big pro, however, was that I could use facilities and equipment usually whenever needed, so less planning was required.
Collaboration is crucial for most of the work we do. We collaborate with people in other labs, institutes, and countries to broaden our skills base and to address biological questions in new and innovative ways. We have ongoing collaborations with biologists, engineers, bioinformaticians, and mathematicians, all working with us on our research questions. The current project on COVID-19, for example, was catalysed by an ongoing collaboration with a group in Bristol. We are using our expertise to generate tailored cells for these COVID-19 experiments.
In addition, this project is a prime example of the power of collaboration between industry and academic research. I myself work at the Milner Therapeutics Institute, part of the University of Cambridge, where I've been developing a method of knocking out multiple genes at once. This has been a really valuable asset for this project, where there are a few different receptors we're planning to knock out, and we need to do it as quickly as possible and also get all of them knocked out in the same cell. Coronavirus is one of the biggest media stories ever. I myself, as a researcher, am determined that the right scientific message is sent out. It can be really difficult for the public at large to stay up to date with research, as it's moving so quickly at the moment. I think it's important that videos like this are done, that people can see how science really works on the ground. A lot of friends and family asked me about what information can be relied upon. So I felt it was important to help out with this interview to give people an insight into our work.
Well, this is difficult to say, ideally as soon as possible, but reality is science is never as easy as that. We hope to generate the specialised cells in this coming month and be able to send these to our collaborators in Bristol. That way they can begin some preliminary experiments with the virus.
Before this project, I was also working to identify the most productive megakaryocytes in our cultures, so we can generate as many platelets as possible from our starting cultures of stem cells. During lockdown, I was also doing some final data analysis and writing this up as a paper.
Well, we hope that the cells generated for this project will also be useful for our longer term goals of understanding virus megakaryocyte interactions.
In addition to the cells, the efficiency of the protocols we're developing for making receptor knockouts will be useful for future targets the GAVERT lab wants to investigate, and more broadly for the expansion of research into a range of different diseases.